There are two robots, Robot A with a mass of 20 kilograms that's moving at 20 meters per second, and Robot B which is moving at 12 meters per second. And they hit each other. Robot B is not moving, and it launches off with a angle of 30 degrees with an initial velocity. So you have to do the equation ma times va in the x plus mb times vbx is equal to ma times the velocity of robot A plus mb times the velocity of robot B, but the final velocity. Then we have to isolate the final velocity of the second robot, and that is going to be equal to the mass of robot A times the velocity of initial velocity of robot A, plus the mass of robot B times the initial velocity of robot B, minus the mass of robot A times the final velocity of robot A, divided by the mass of robot B. Okay. The next part of the problem we have to plug in our variables. So we have to plug in the mass of robot A, which is 20 kilograms, times the initial velocity, where it's moving at 2 meters per second in the x direction. Plus, then we have to add that times the mass of robot B, which is 12 kilograms. But since it's not moving, it's going to be multiplied times zero velocity. So that part's basically obsolete. Then we have to subtract that times our 20 kilograms and multiply that by the velocity it's launched at the angle, which is going to be 1 meters per second. But then we have to find that in the x direction, so we multiply that times cosine times our angle and divide it all by our mass of robot B, which is 12 kilograms. You do all the math, and you get that the velocity in the the final velocity x direction is 1.89 meters per second.
There's no way to rank them.
Like 90% psyched.
Okay, next we do the same thing, but we do the mass times the initial velocity, but this time in the y direction, plus the mass of robot B times its initial velocity in the y direction, which for both of them is 0. Then we set that equal to our mass of robot A times its final velocity in the y direction, plus the mass of robot B times its final velocity in the y direction as well. Then we do the same thing. We isolate the final velocity of robot B in the y direction, which is going to be equal to the mass of robot A times its initial velocity in the y direction, plus the mass of robot B times its initial velocity in the y direction, minus the mass of robot A times its final velocity in the y direction, divided by the mass of robot B. We then plug in our variables, which is going to be our 20 kilograms, but since it's only moving in the x direction, it's going to be multiplied by 0, plus our 12 kilograms of robot B, but it's not moving at all, so its initial velocity is also 0, subtracted by 20 kilograms times its 1 meters per second, and then we do our sine of 30 degrees so we can find its velocity only in the y direction, divided by the 12 kilograms of robot B. You do the calculations, and then the final velocity of robot B in the y direction is going to be equal to negative 0.83 meters per second. Next up, since we have the x and y components of its velocity, we find the overall velocity of robot B, the velocity of robot B, where we do Pythagorean theorem, which is, a squared plus b squared equals c squared. So we do 1.89 meters per second plus our negative 0.83 meters per second. And we square both of those, and then we take the square root of that to find our c value, which is 2.1 meters per second. Then we have to find our angle, which we can find using the inverse tangent. Where we then do our opposite over adjacent, so our negative 0.83 over 1.89 meters per second. And that would get you our angle of negative 24 degrees. So the final velocity of robot B is going to be equal to 2.1 meters per second at an angle of negative 24 degrees. And that is the problem 8.69. Thanks for listening.